All right, we're going to be looking into energy and the kinetic theory associated with it. We know we've been discussing endothermic and exothermic reactions and occurrences in class. We're just going to take a little deeper look into that. Again, to reiterate what endothermic is, we talked about that endothermic means that you're putting energy into the system. That's why when we were doing things like talking about boiling something or melting something or even sublimation, the idea was that you had to put energy into the system in order for it to get to a higher energy level and melt or boil or vaporize. But also, if we talk about chemical reactions, sometimes the word saying adding in the energy isn't as clear. Sometimes the system absorbs energy, means takes in energy, in order for the reaction to occur. If we're talking about exothermic reactions, we know that the system is releasing energy into the surroundings. For a chemical reaction, if we end up having it react and we put our hands by it or touch it, this reaction should definitely feel warm to us because it's giving off heat. As opposed to an endothermic reaction, when we hold it, it should feel cold to us because it's pulling in the heat. So again, exothermic reaction, the energy is being given off. Where if we had an endothermic reaction, it's either pulling energy in, like heat from our hands, or we're having to put energy into it in order for it to work. But anyways, exothermic reaction, we know that it's like freezing or condensation forming because you have to get rid of the energy in order for it to drop to a lower energy level and freeze or condense. As for chemical reactions, if we need more energy in the beginning to actually start the reaction, meaning that the reaction is pulling energy into itself in order to go, that is going to be an endothermic reaction. And again, to reiterate for the second time, if it's pulling in energy, it should feel cold to us because it's pulling the heat away from our hands. Now, if the reaction is exothermic, as that reaction is occurring, it would be giving off energy or heat. In that case, if energy is leaving the system, that means it would feel warm to us. So that's how we would know that it's exothermic. If you take a look at this final question, it says, which of the following would best represent why a chemical reaction between hydrogen and oxygen is an exothermic reaction? So, if we take a look here down at this table, we have options A, B, C, and D. The first column is actually how much energy is required to put into the system to break the bonds and actually have a reaction. The second column is actually how much energy is given off once the new bonds are formed as products, or meaning after the reaction occurs. Well, if this is exothermic, we want to look at the end result, meaning if energy is being given off, that means more energy should take place after the reaction occurs. So if you take a look at it, the only option available is letter A that has the larger number on the second column. That means that you had to put energy into it in order for the reaction to occur, about 2,500 kilojoules. Now remember, we haven't really gone through joules yet, but joules is similar to what we think of as calories or units of energy. But anyways, a kilojoule is like a food calorie. But moving forward here, since this is less energy in the first column and more energy in the second, it's definitely saying that energy is being given off after the reaction and new bonds are formed. So that would definitely be an exothermic reaction. So if you run into this idea where the energy is given for before and after the reaction, if it's exothermic, the second column or after the reaction and new bonds are formed should be larger. If it was endothermic, it would be reverse. The first column would be larger, than the second column. Quick question for you. If we're boiling water, we're going to use heat, of course. And as the water heats, we know that those particles are slowly going to move faster and faster and faster. In fact, that liquid water is going to eventually vibrate so fast that the attractive forces, the things that are holding that liquid together, will get so much energy that they'll break apart and turn to a gas. Now, since we have to put heat into the system in order for this to occur, Is that endo or exothermic? Yes, definitely it would be endothermic because you had to put heat into the system. When we think about the effects of energy and temperature, we should look into the kinetic theory. If we think about gases specifically, gases are just these little tiny particles, and they're constantly bouncing around, bouncing off each other in random motion. And because of that, there's actual utter chaos, right? But the more energy it has, or the more heat it gets, the more bouncing around. So if our energy goes up, so does our temperature. And that's what a lot of the kinetic theory is about. The more energy we have, the higher the temperature will be, and vice versa. If we think about the kinetic energy then and take it a step further, why does a hot air balloon actually inflate and float? It has to do with something that's a side effect of the kinetic theory, and that's thermal expansion. Thermal expansion is basically when you have a higher temperature, you get a higher energy, as we stated in the last slide. But since we have a higher energy, there's going to be an expansion, or meaning the spreading out of the gas particles, because they bounce harder and are actually going to create larger distance between them. Because of that, they'll end up expanding and they can inflate the balloon. Now the opposite happens if a gas is cooled. Since it's lower energy when it's cooled and lower temperature, that means that these things are going to start getting closer together or contract. If they're closer together and contract, they tend to be more dense. So that means a hot air balloon that cools won't float as well and will actually start falling slowly towards the earth again. So if you cool off your hot air balloon, you won't float as high. This has a lot to do with the kinetic theory. All right, so keep these couple things in mind here. Higher temperature, higher energy; lower temperature, lower energy. Thanks for listening, and best of luck with your phi-sci.